Hey guys, welcome to our channel Campus Coders. This is Sanjay JK. I am a student from VIT Vellore, currently pursuing BTech Computer Science second year. So, me and my friend Karthik, we have started this channel to share our knowledge on DSA and learn together through this. So, personally, I have solved more than 200 questions in lead code. So, yeah, let's start with this. So, we have planned to create a DSS series right from basics to advanced throughout this. So, the language would be mostly English and occasionally Tamil as well. And in this video, we will cover up some easy questions on arrays. And this is our first question. Given an array of length and find the second largest element in it. So, while seeing this question, our first approach would be basically sort the array and find the n second largest element through the index. But that isn't the case in every cases because let's say let's say we have an array like y 1 3 5 4 6 6 5. Okay, so if we sort this array, we will get like 1 3 4 5 5 6 6, right? So in this one we cannot just take the n minus 2th element as the second largest element because we have some duplicates, right? So just by having this one we cannot by sorting and finding the second element from the last, we cannot say that it's going to be the second largest element. So this is not the right approach, right? In all the cases, although each time complexity is way less because sorting just takes log n complexity, but it isn't going to give us the correct answer every time. So what will be our approach here? So one thing could be having two pointers, let's say m1, which we are going to store the maximum element in this variable, and then m2, this is here we are going to store the second largest element, and we are going to traverse each and every element in this array and check few conditions, and then add it into the m2 and m1 variables. So every element in the array will be going to be either greater than m1 or in between m2 and m1, or it should be less than m2. This is our case we are going to find. So initially we will initialize m1 and m2 to be int minimum, and then first let's say if the element is greater than m1. So if it is greater than m1, so we are going then that element is going to be the maximum element, right? So we are going to initialize that ai to be m1, and if we are changing the maximum element, we have to change the second maximum element also, right? So what does the second maximum element value will be? So it will take the value of m1 with previous value of m1. So before this we are going to change the value of m2. M2 will be equals to m1, right? So this is the case if the element is greater than m1. So if it is between m1 to m2 and m1, we are going to just change the value of m2, that is equal to the value inside that index, that means the value of the element in that array. So there is no change, there is going to be no change in m1 because it is less than the element. So this is not going to affect the maximum element. And same way, if it is less than m2 and m1, it's not going to affect the maximum values. So this case we are going to do nothing. So this is our approach, and code will be something like this. Let's say we will take a function int sec largest, parameters will be int arr, and then int n, which denotes the number of elements in this, and then we will initialize int max1 equals to int min, int max2 equals to int min, and traverse it the I is equal to 0, I less than n, I plus plus, and check our first condition. If error of I is greater than max 1, we are going to do two things. First, change the value of max 2 to the value of max 1, and then change the value of max 1 to the current element, right? So, and we are going to check the other case. If here of I is between max 1 and max 2, less than here of I, at this case we are going to change the value of max 2 to error of I, and this will be the case. We will return the max 2 element, and this is going to give us the second largest element in the array, and this is it in this question. Moving on to next question. This question says remove duplicates from a sorted array. So given a sorted array, there will be multiple elements, so we are going to remove all those duplicates and just give the unique elements in the array. So one way is to create a set and then add all the elements in the array into the set. And since set can only store unique elements, we can just retrieve the set again and then show the unique elements. But the time complexity will be greater because traversing the array will take O(n) time complexity, and then inserting an element in set takes log n complexity. So totally it will be O(n) into log n. So this is not the optimized approach. So optimized approach would be using two pointers. So let's say we have an pointer I and pointer j. I initially stores the first element and j starts from 1 till the end of the array, and we are going to check if I ith element is not equal to jth element, then we are going to add the element in the jth position to the I plus 1th position. So the code will be something like, let's say, first we will initialize int I equal to 0, so, and then traverse from j equal to 1, j less than n, j plus plus plus. So if error of I not equal to error of j, we are going to increment the ith pointer and then initialize that position into the new variable. So when we are doing like this, we will be having the unique elements in the first I position. So we're going to return I plus 1. So to understand this algorithm, here's the step-by-step way of how this algorithm works. So first, initially I is in the 0th position, j is in the first position. So we check if a of I is not equal to a of j, and since they are equal, we are incrementing j pointer now. So j is in the second position, when we are checking if I and j are equal. Since they are not equal, we are incrementing I to I plus 1 position and then changing the element in the I plus 1 position to the element what is present in the j. So this becomes 2. The similar way, when we check for the other elements, we will have, whenever there is some difference between the elements, we are going to change the next element into the new element. So a similar way, if we do the first uh, from the first till the I till the position where I pointer is present, that will be consisting of unique elements. So the, and when we just take this part of the array, we will get the uh, unique elements and remove all the duplicates from the sorted. Moving on to next question. This question says we have to rotate the array of elements by k elements, either left or right, whatever is given. So our approach should be first creating a temporary array, and then using that we are going to shift elements either left or right. So first we will say check how to rotate right side. So we are creating a temporary array. First thing is, either if the array has 10 elements and they have asked us to rotate the elements by k, which is greater than n, then obviously for first n times rotation it will come into the same array, right? So after n times, whatever extra buffer we have, that many times only the array will change. So if we are going to change the array by n times, it will rotate and come again to the same position. So we are going to do this operation k is equal to k star n, so that we will reduce the number of rotations whatever is asked. So after doing that, we are creating a temporary array, and then first we are going to take the first n minus k elements and store it in the temporary array, and then shift the elements k time k positions to the right, and then copy those elements again back to the array. The similar way we are going to do for the rotation to the left, but here we are going to take first k n minus k elements, and then we are going to do the operations. Though this is of O(n) time complexity, but we are having extra space complexity as O of n. To reduce the space complexity, we need to rotate the elements within that given array itself. To do this, we are going to see how the array rotation takes place. For example, if we are having an element array like 1 2 3 4 5, for example, and then they asked us to rotate it by two elements to the left, let's say. So it will be 3 4 5 1 2. So to if we observe this, it's it's like first two elements we are going to reverse it first. What happens if we reverse the first two elements? It will be become it becomes 2 comma 1, right? And then if we reverse the next three elements, it will becomes 5 4 3, right? And if we reverse the whole array now, it becomes 3 4 5 1 1 2, and this is the required output which we need, right? So by based on this observation, we can say like reversing two different parts of the array, and then reversing the whole array gives us the required solution here. So based on the observation, we can do this operation like first, when we are going to rotate it to left, so first k elements we have to reverse separately, and then reverse last n minus k elements. That means the rest of the elements separately, and then reverse the whole array again. This will give us the final rotated array. Same for rotate right. First n minus k elements we are going to rotate and reverse last k elements, and then reverse the whole array. This is going to give us the rotated array. So moving on to next question. Here they are given two sorted arrays of different sizes. We are going to find the union of two sorted arrays. For example, if the array 1 is this and the array 2 is this, we are going to intersect these two arrays and give the output without any duplicates. So this is how the question is. So the normal approach would be first finding using let's say a map or a set, and add all these elements into this set or the map. Since we are not going to use unordered map or unordered set, because here we need the output to be sorted. So if we use map or set, we will get the output in the required ascending order. So we will use map or set, add every elements into it, and then using the frequencies we can just again take it out and add it to another array and give it as an output. But this takes extra space and extra time complexity, because inserting an element into map or set will take log n complexity, and here we are going to add elements of two arrays, so it will take log n plus m complexity, as well as traversing them it will take O of n plus m. So this has a lot more time complexity as well as space complexity, right? So this is not the optimized way of doing this question. So optimized way would be again using a two pointer approach. So first we will create a, a vector or an array, let's say, to store the final answer, and we will use two pointers, obviously, int I equal to 0, j equal to 0. Let those two pointers be in the initial position of each array. Okay, so we are going to traverse till the end, so while I less than n and j less than m. So our idea is, whenever the elements in ith position and jth position are equal, we are going to push it to the answer array and then increment those operators. So when error of 1 of I is equal to error of 2 of j, then we are going to push back the element. Since both elements are same, so we can just take any one of it and push it inside, and then I plus plus j plus plus. We are going to increment those arrays, right? So else, if array element first element is less than second array element, in this case we are just going to increment the operator in the first array, because since it is lesser, then we will have something equal to the second array element, right? So we were going to increment the second operator, and if element in the second array is less, that means the other case we are going to increment the j pointer. So while doing this, we will get the required vector array. So this is the way of doing this question in the more optimized way. Here the time complexity will be O of n, whichever is greater. If the array size is greater in n, it is going to be O of n. If the array size is greater in m, so it will be going to be O of n, and there is no extra space complexity. There is extra space complexity. Yeah, we are having an creating a new array, and we are going to append it out. So the extra space complexity will be O of n plus m, or the union of it, right? So yeah, that's it. Moving on to next question. This question says, find unique elements in an array. So there will be duplicates of all the elements in the array. There will be one element which is unique, and we're going to find that element. So the normal way of approaching is first sort the array. So sorting the array, after that we will get all the elements in sorted order, and we can check the adjacent elements. So if the adjacent elements are not equal, we are going to return the first element. That's going to be the unique element, right? Or if there is no adjacent elements equal, the last element will be the unique element. So it will be something like int I equal to 1, I less than n, I plus plus. If error of I not equal to error of I minus 1, return error of I minus 1. So this is the approach, or else return error of n minus 1. This is the usual approach, and this takes time complexity of O of log n into O of n. So O of n into log n, right? So to optimize this further, one we are going to use a method called XOR. So XOR uh, truth table, right? So if the elements are equal, let's say A and then A, and if we are going to do XOR between these two equal elements, it's going to give us 0. And if it is 0 XOR A, it's going to give this same element A. Based on this observation, we can now say that if we XOR all the elements in the array, it will, and the final answer is going to be the unique element, right? So let's take every pairs of duplicate elements. Doing XOR will give us 0, and this is going to give us 0, and this is going to give us 0. Similar way, all the pairs is going to give us 0, and now 0 XOR that unique element is going to give us the unique element, right? So using this property, we can say like this is going to give us the answer. Let's say int answer is equal to 0. For int I equal to 0, less than n, I plus plus, answer is equal to answer XOR air of I, and return answer. So this is optimized approach of doing this question. This is going to be O of n lot time complexity, and there is no extra space complexity, just O of n. Right? So last question of this video: given an array and an integer target, we have to find the uh, integers of two numbers such that their sum is equal to the target. It's just the two sum question, right? So the normal. Let's take an example first. Okay, let's take 3, 5, 6, 2, 1, and target will be, let's say, uh, 8. Okay, so the normal approach would be some like having two for loops inside each other, and if their sum is equal, we are going to return those two integers, right? This is the normal approach we will be thinking, but this takes O of n squared complexity, obviously. So optimized approach would be either using an unordered map, or either using a two pointer approach. I will discuss both of those approaches, and both are equally optimized approach. Let's discuss one by one. So first thing is either you first using map. So let's take one element from this array, let's say 3. So if we take 3, what is the other number we need to have so that it we will get the target 8? It's 5, right? So we are, so by this approach we will be seeing like if there, for every element, whether there exists another pair such that the target is met. In this way we will check and return the necessary answer. So the code would be something like, first unordered, I will just write the code what will be inside the function. You can just call the function, give the parameters and the return type according to the whatever given in the question. I will just give the gist of what is necessary in this, in the type of questions which is asked here, because these are normal simple questions which can be asked. So creating an unordered map, right? So traversing the element less than n I plus plus. So first we will store the element for now, and then the paired element, let's say it's extra, it will be target minus num, right? So then we are going to check if this extra element is present in the map or not. Without hint. This is the syntax to find an element present in the map, or not a map here. If it is present, return those indices extra, comma, I, right? If it is not present, then we are going to return minus one, comma minus one, whatever they have asked. And after this we change need to update the map, right? So in every iteration we need to update the map. So mp of num will be high. So by this way we can say find the indices of two numbers such that the sum is equal to target. This is one method. This takes O of n time complexity, but at worst case, it can go to O of n square as well, because at very rare cases, unordered map can take O of n time complexity to search an element at very rare cases. So at that time, it will be O of n square. So to avoid that situation as well, we can do another approach, which is using two pointers, or this can come under a concept called binary search, which we will discuss later, but I will just say you gist of it. It's like finding an word in a dictionary. So if you are finding, let's say, the meaning of the word mango in a dictionary, we are not going to search right from the first or right from the last. Like, you will see to the middle element and check if the word is less than that middle element or greater than that middle element, right? If it is greater, we are going to see the second half of the dictionary, or if it is lesser, we are going to check the first half of the dictionary. So this way we are going to do the binary search. It's something related to this one. So first, here we will sort the elements. So because binary search works only with the sorted array, so first we are going to sort the array. Then we are going to obviously have two pointers. First is in the initial starting, and then the other one in the end of the array. So while left is less than right, we are going to check, yeah, every elements until left pointer reaches the right pointer. So it should always be less than right. So where left is less than right, int sum is equal to arr of left plus arr of right. First, we are going to have the sum of those two elements, and then check if sum is equal to target. We are going to okay, we are going to return yes, whatever is whatever they are. We can also return the those pointers. You can return this. Else, if sum is less than target, so it means there exists some extra element which should be added so that it would be greater, right? So we need to increment the left pointer. Else, if sum is greater than target, we are going to decrement the right pointer. So by this way, we can say and find the sum target. That's it for today's video. I hope you have learned a lot of things in this video. The links to the questions will be given in the description below. You can definitely check it out and practice them. You can follow me in LinkedIn and Instagram. The link will be given in the description below. So yeah, I will meet you in the next video. Until then, keep coding. Bye bye.